Hello students, let us read this question. Find the inverse of the matrix if it exists. So we have been given one matrix and we need to calculate the inverse of the matrix. So we know that inverse of a matrix A is given by 1 upon determinant of matrix A times adjoint of A. Now in order to check whether the matrix for a matrix if inverse exists or not, we need to calculate the determinant. If the determinant comes out to be not equal to 0, we can say that inverse for that matrix exists. So first, let us assume that the matrix A is equal to 1 minus 1 2, 0 2 minus 3, 3 minus 2 4, and we will calculate the determinant of this matrix. So determinant will be 1 into 2, 1 into 2 into 4 is 8 minus of minus 2 into minus 3 will be plus 6. So this will be 8 minus 6. Then minus of minus 1 will be plus 1 into this will be 0 into 4 which is 0 minus of minus 9 which is plus 9. Then plus 2 times 0 into minus 2 will be 0 minus of 6. So determinant comes out to be 1 into 8 minus 6 which is 2, 2 plus 9 plus 2 into minus 6. So this is 11 minus 12 which is minus 1. So our determinant comes out to be minus 1 which is not equal to 0. So we can say that since it is not equal to 0, we can say that inverse exists. Now let us calculate the inverse. Now in order to calculate the inverse, we will first calculate the adjoint, and to calculate the adjoint, we need to calculate the cofactor matrix. Now cofactor matrix, if we take a transpose of cofactor matrix, we will get the adjoint of matrix. So let us first write our matrix here. So it is 1 minus 1 2, 0 2 minus 3, 3 minus 2 4. So this is our matrix A. Now we can calculate minors. So in order to calculate minor, we have to hide the corresponding rows and columns and find the determinant of the remaining element. So for M11, we will hide first row and first column. So the remaining determinant of the remaining elements is, so this will be 8 minus of plus 6. So this is 2. That M8, sorry, M12 will be a first row, second column. So this is 0 minus 3, 3 and 4. 0 minus 3, 3 and 4. So this will be 0 minus of minus 9. So it will be plus 9. 9. Then M13 will be first row, third column. So this will be 0, 2, 3 minus 2. So this is 0 minus 6 which is minus 6. Then M21 will be second row, first column. So this is minus 1 2 minus 2 minus 1 2 minus 2 4. So this is minus 4 plus 4 which is 0. Then M22 will be, M22 is 1 2 3 4. 1 2 3 4. It is 4 minus 6 which is minus 2. M23 will be, M23 will be 1 minus 1 3 minus 2. 1 minus 1 3 minus 2. This is minus 2 plus 3 which is plus 1. Then M31 will be third row, first column, minus 1 2 2 minus 3. Minus 1 2 2 minus 3. So this is 3 minus 4 which is minus 1. Then M32 is third row, second column. So 1 2 0 minus 3. 1 2 0 minus 3. It is minus 3. And M33 is third row, third column. So it is 1 minus 1 0 2. It is 2 minus 0. So it is 2. Now we will calculate the elements of the cofactor matrix. So it is A11, which is given by minus 1 raised to 1 plus 1, M11. So it is M11 is 2. So 1 into 2 is 2. Then A12 will be minus 1 raised to 1 plus 2, M12. M12 is 9. So minus 1 into 9 will be minus 9. Then A13 will be minus 1 raised to 1 plus 3, M13. M13 is minus 6. So 1 into minus 6 will be minus 6. A21 will be minus 1 raised to 2 plus 1, M21. So M21 is 0. So this will be 0. A22 is minus 1 raised to 2 plus 2, M22. M22 is minus 2. So 1 into minus 2 will be minus 2. A23 will be minus 1 raised to 2 plus 3. 2 plus 3 into M23. M23 is 1. So minus 1 into 1 will be minus 1. Then A31 will be minus 1 raised to 3 plus 1, M31. So 31 M31 is minus 1. So 1 into minus 1 is minus 1. M32 is minus 1 raised to 3 plus 2, M32. So M32 is minus 3. Now minus 1 into minus 3 is plus 3. A33 will be minus 1 raised to 3 plus 3, M33. Now M33 is nothing but 2. So 1 into 2 is 2. So we can calculate the cofactor matrix now. So therefore cofactor matrix A will be 2 minus 9 minus 6, then 0 minus 2 minus 1, then minus 1, 3 and 2. So this is the cofactor matrix. Now if we take the transpose of this, we will get adjoint of A. So transpose means we need to uh, interchange the rows with columns and columns with rows. So this will be 2 minus 9 minus 6, then 0 minus 2 minus 1, then minus 1, 3 and 2. Now since we have calculated the adjoint, we can now calculate the inverse by the formula 1 upon determinant of A into adjoint of A. So therefore inverse of A will be, we have calculated the determinant to be equal to minus 1. So this is minus 1 into adjoint of A is 2, 0 minus 1, 2, 0 minus 1, minus 9 minus 2, 3, minus 9 minus 2, 3, and minus 6 minus 1, 2, minus 6 minus 6 minus 1, 2. So this is the inverse of the given matrix. So in this question, we have calculated the inverse of a given matrix. So I hope you have understood it well, and thank you.
Don't forget to like and subscribe.